The calibration strip method is one of many calibration methods used for boom and boomless sprayers. The strip method determines the time required to spray a portion of an acre and then converts that to a per acre basis. Some applicators fill their spray tank with water, spray an entire acre, and then determine how many gallons were used. To save time, why not only spray a quarter of an acre, determine how many gallons were used, and then multiply by 4? With the calibration strip method, the area of the strip is the width of your spray swath or pattern in feet multiplied by a distance of your choosing. Most applicators use 100 to 200 feet. Before you begin calibration, it is crucial to determine your field speed. After all, speed affects output. To determine your field speed, follow this calculation. Distance in feet times 60 divided by the time in seconds multiplied by 88. To calibrate a boomless or broad jet sprayer, begin by laying out a calibration test strip. The first measurement will be the width of your spray swath as it appears on the ground. The next measurement will be the length of your test strip. For this example, we will use a 200-foot long strip. To determine the area of your test strip in acres, multiply the swath width in feet by the length and convert to acres. 200 feet times the swath width divided by 43,560, the number of square feet in an acre. Fill your sprayer with clean water. From a running start, drive the length of the test area and record the time required. For the same time it took you to drive the calibration strip at field speed, collect water from the nozzles using the same pressure as you would in the field. Measure the amount collected and convert to gallons. For this example, if your boomless sprayer has a swath width of 30 feet and we use a 200-foot test strip length, the area of the calibration strip is 6,000 square feet. To convert this to acres, divide 6,000 by 43,560. This gives us an acreage number of 0.1377. When you drove the calibration strip, it took 27 seconds. When you stop and collect the water from under the nozzle for 27 seconds, you collect 3 gallons. 3 gallons divided by the acreage, 0.1377, gives you a gallons per acre output of 21.78, or, rounding it up, 22 gallons per acre. Calibrating a boom sprayer can be complicated by the fact that you want a fairly uniform output across the boom. This can be done by checking nozzle accuracy. Check the nozzle manufacturer's specifications for nozzle output rates at various pressures. This will help you determine if any one nozzle is applying more or less than it should. In general, any amount 5% over or under the specifications for that nozzle indicate that it needs cleaning and/or replacing. Furthermore, check the manufacturer's recommendations for nozzle spacing, pattern overlap, alignment, and boom height above the target pest. These factors are all important in broadcast applications because it affects uniformity of the spray pattern. Once you have checked all your nozzles for uniform output, the calibration process is similar to calibrating a broadjet. Find the effective swath width created by all of the nozzles. Mark out a 200-foot course to verify your speed. Time yourself in seconds. Multiply your swath width by 200 feet to find the area of your calibration test strip. Determine the acreage of your calibration test strip by dividing the calibration test strip area by 43,560. Collect liquid from each nozzle for the amount of time it took to drive the test strip and pour the liquid collected from all of the nozzles into one container. Convert this amount to gallons. For this example, suppose we have a swath width of 10 feet. Multiply 10 feet times 200 feet for the length of your test strip. The area is 2,000 square feet. To determine the acreage of the test strip, divide 2,000 by 43,560. This gives us an acreage of 0.0459. Driving the 200-foot course takes us 27 seconds. When we stop and collect from each nozzle for 27 seconds and collect it into one container, we get 1 gallon and 1 quart, or 1.25 gallons. If we take the 1.25 gallons collected from all nozzles and divide by the acreage of 0.0459, that gives us a 27 gallon per acre output for our sprayer.